This video describes how InfoFramework, a statistical framework for experimentation and rapid prototyping, can be used to create a prototype of an embodied conversational agent with a specific emotionality. Given you develop an emotional embodied conversational agent, let's call it Max, which performs believable actions in terms of emotions. For example, Max shows actions typical for his emotionality during typewriting. The central point of Max is his emotion model that should be programmatically feasible to integrate it in an embodied conversational agent. Moreover, this model must allow adjustment according to a concrete person. These requirements are made by Picard's hidden Markov models for effective behavior that on the one hand provide an approximation of human emotionality, on the other hand can be implemented computationally. Our proposal for Max emotion model, a hidden Markov model for effective behavior with 5 states: high negative, high positive, neutral, low negative, low positive, with transition arcs between states and the states observations. Initially, probabilities are not initialized, that's why question marks. To initialize probabilities, we use training sequences based on dialogues from the sensitive artificial listener cell corpus that contains 27 effective dialogues with 4 characters with different psychological properties trying to draw the user in the emotional state. To train Max hidden Markov model for effective behavior, we use utterances of a confrontational and argumentative character in the cell corpus. Cell utterances are notated manually by 4 persons that we map onto 5 effect segments. Here is the 5 segments model in the evaluation activation space. The utterances are annotated with 5 effect segments that have the same names as hidden Markov model states, since a state and an utterance correspond to the same emotion. Labels of consecutive utterances in a dialogue are effective sequences used to train the hidden Markov emotion model. We use InfoFramework to generate and evaluate Max emotion model as well as to create its software prototype. For this purpose, we develop custom Python classes corresponding to effective training sequences and a custom generator function. The Generate button starts generation of a dataset with Max emotion model. Generation is finished and the generate dataset file is stored in the directory specified in the preferences. Next step is evaluation of the generated dataset in the Evaluation tab. The Evaluation tab controls statistical evaluation of the generated emotion model. As the basis classifier, we use the HMM classifier with 5 states from the HMM vector package. The Evaluate button starts evaluation. The evaluation is finished. The recall value averaged over 5 classes is about 46%. We can observe the confusion matrix of the evaluated dataset in the tooltip. The final step is creation of the Max prototype. For this purpose, we define the basis classifier that will be used in the new prototype program HM, the root directory for the composed NetBeans project and Java sources, the prototype name, the dataset with max emotion model. The Generate Prototype button creates a Java prototype servlet. The prototype creation is finished. Now the framework allows to review the prototype. This can be done by clicking the Review Prototype button that will compile the Java source of your prototype, start an internet browser, and show the prototype just created by the framework. Afterwards, the prototype can be adjusted in your favorite Java developer environment, for example NetBeans. Thanks for your attention.